Welcome to our exploration of SpaceX's Starship project, a venture that promises to redefine our relationship with space. Let's begin by examining the sheer scale of ambition behind this endeavor. Can you elaborate on how Starship's technical specifications compare to previous spacecraft, and what this means for our capabilities in space?
Certainly, Starship represents a quantum leap in spacecraft design. Unlike previous vehicles, it's fully reusable and capable of carrying up to 100 tons to low Earth orbit. To put this in perspective, that's more than double the payload capacity of the Saturn V, which took humans to the Moon. But what's truly revolutionary is Starship's versatility. It's designed for both Earth orbit operations and interplanetary travel. This dual capability has never been achieved before and opens up unprecedented possibilities for space exploration and colonization.
That's a remarkable advancement. How does this capability align with SpaceX's vision for Mars colonization? It seems like a critical piece of the puzzle.
Indeed, it's the linchpin of SpaceX's Mars ambitions. Elon Musk envisions a future where we establish a self-sustaining city on Mars, and Starship is the vehicle designed to make that possible. Its large payload capacity allows for transporting not just astronauts, but also the massive amount of equipment and supplies needed for long-term habitation. The ability to return to Earth and be rapidly reused is crucial for maintaining a consistent supply chain between the two planets. This is not just about planting a flag, it's about creating a permanent human presence on another world.
The economic implications of such a fully reusable system are profound. How might this reshape the space industry as we know it?
The impact could be transformative. Currently, the high cost of launching payloads into orbit is a major barrier to space development. With Starship's reusability, we're looking at potentially reducing launch costs by orders of magnitude. This could democratize access to space, enabling more countries, companies, and even individuals to participate in space activities. We might see an explosion in satellite deployment, space manufacturing, and even space tourism. The ripple effects on Earth's economy could be substantial, from new industries emerging to radical changes in global communication and resource management.
As we contemplate these exciting possibilities, we must also consider the ethical dimensions. What are some of the key ethical considerations surrounding Mars colonization and the increasing role of private companies in space exploration?
This is a crucial point. There are several ethical concerns we need to grapple with. First, there's the question of who has the right to colonize Mars. Should it be first come, first served, or should there be international agreements governing extraterrestrial settlement? There's also the issue of potential contamination, both of Mars by Earth life and vice versa. We need to consider the impact on any potential Martian biosphere. Additionally, as private companies take a leading role, we must ensure that space doesn't become a new frontier for unchecked corporate power. There are questions of worker rights, resource exploitation, and the potential militarization of space. Balancing progress with responsible governance will be a significant challenge.
These are complex issues that will require careful consideration as we move forward. Now, let's pivot to the engineering challenges. Developing a craft capable of both Earth orbit operations and interplanetary travel is no small feat. What are some of the key hurdles that SpaceX has had to overcome?
The engineering challenges in developing Starship are indeed formidable. One of the most significant hurdles has been creating a vehicle that can withstand the extreme conditions of both launch and re-entry, while also being capable of interplanetary travel. This requires innovative solutions in propulsion, materials science, and thermal management, among other areas.
Let's dive deeper into some of these innovations, starting with the Raptor engine. How does this new propulsion system differ from previous rocket engines, and why is the choice of methane as fuel so significant?
The Raptor engine represents a major leap forward in rocket propulsion technology. It's the first full-flow staged combustion cycle engine ever to fly, which allows for higher efficiency and power output. The use of methane as fuel is particularly interesting. Unlike traditional rocket fuels like kerosene, methane can be produced on Mars using local resources through a process called the Sabatier reaction. This is crucial for enabling return trips from Mars and sustaining a long-term presence there.
That's fascinating. It's not just about getting there, but about creating sustainable systems for long-term exploration. Speaking of sustainability, let's talk about the heat shield. Re-entry from interplanetary velocities poses extreme challenges. How is SpaceX approaching this problem?
The heat shield for Starship is indeed a critical component. SpaceX has developed a unique solution using hexagonal tiles made of a proprietary high-temperature ceramic. These tiles are designed to withstand temperatures up to 1400 degrees Celsius during re-entry. What's particularly innovative is the way these tiles are attached to the vehicle. They're mechanically fixed rather than glued, which allows for easier replacement and maintenance. This is crucial for a rapidly reusable vehicle like Starship.
Intriguing. It seems like every aspect of Starship is pushing the boundaries of what's possible. Another groundbreaking concept is in-orbit refueling. Can you explain why this is so important for deep space missions?
Absolutely. In-orbit refueling is a game changer for deep space exploration. Traditionally, the amount of fuel a spacecraft can carry has been a major limiting factor in mission design. By refueling in orbit, Starship can depart Earth with a full fuel load, dramatically increasing its range and payload capacity for deep space missions. This opens up possibilities for missions to Mars, the outer planets, and even beyond our solar system that were previously unfeasible.
That's truly revolutionary. Now let's talk about an unexpected choice, the use of stainless steel in Starship's construction. This seems counterintuitive in an industry that has long favored lightweight materials like aluminum and carbon composites. What advantages does stainless steel offer?
You're right, it does seem counterintuitive at first. However, stainless steel offers several key advantages. First, it's significantly cheaper and faster to work with than advanced composites, which aligns with SpaceX's rapid iterative development approach. More importantly, stainless steel actually performs better than composites at the extreme temperature ranges Starship will experience. It has a higher melting point and better strength-to-weight ratio at cryogenic temperatures. Additionally, in the event of micrometeorite impacts, steel tends to dent rather than puncture, which could be crucial for long-duration space missions.
It's remarkable how sometimes the best solutions come from rethinking our assumptions. Lastly, let's explore the role of artificial intelligence and automation in Starship. How might these technologies enable autonomous operations on Mars?
AI and automation are set to play a crucial role in Starship's operations, particularly for Mars missions. Given the communication delay between Earth and Mars, which can be up to 20 minutes each way, real-time control from Earth isn't feasible for many operations. AI systems could enable Starship to make rapid decisions during critical phases like landing and takeoff. On the surface of Mars, autonomous systems could manage life support, conduct scientific experiments, and even begin setting up infrastructure before human arrival. The potential for AI to adapt to unforeseen circumstances could be invaluable in the unpredictable environment of another planet.
The integration of these technologies paints a picture of a future where space exploration becomes increasingly accessible and sustainable. As we consider these engineering marvels, it's natural to wonder about their broader implications. How might these advancements in space technology reshape our civilization and our understanding of humanity's place in the cosmos?
The implications of Starship's success for humanity's future are truly profound. As we've discussed, this isn't just about technological advancement, it's about reshaping our civilization and our place in the cosmos. Starship has the potential to democratize space access in ways we've never seen before, potentially ushering in an era of large-scale space tourism. This could have far-reaching socioeconomic impacts, creating new industries and job opportunities while also changing our collective perspective on Earth and our place in the universe.
Indeed, the economic implications extend far beyond tourism. How might Starship facilitate the exploitation of space resources, and what could this mean for our economy and resource management on Earth?
Starship's large payload capacity and reusability make it an ideal platform for asteroid mining and other forms of space resource exploitation. This could provide access to vast quantities of rare earth metals and other valuable resources, potentially alleviating resource scarcity on Earth. However, it also raises important questions about the equitable distribution of these resources and the need for international frameworks to govern space source utilization.
As we consider establishing a permanent human presence on Mars and other celestial bodies, how might this change our species in the long term?
The long-term implications for human evolution and adaptation are fascinating to consider. Living in the harsh environment of Mars or in space habitats would likely drive rapid physiological and potentially genetic changes in human populations. We might see the emergence of distinct space-adapted human subspecies over time. This raises profound questions about what it means to be human and how we might diverge as a species as we spread throughout the solar system.
These are indeed profound considerations. As we contemplate becoming a multiplanetary species, what are some of the philosophical and existential questions we need to grapple with?
The prospect of becoming a multiplanetary species forces us to confront fundamental questions about our purpose and place in the universe. It challenges us to think about the long-term survival and flourishing of our species beyond the confines of Earth. We must consider our responsibilities as stewards of new worlds, the potential for encountering or creating new forms of life, and how we define humanity when we're no longer bound to a single planet. These questions touch on the core of our identity and our aspirations as a species.
As we conclude our discussion on the Starship project and its implications, it's clear that we're standing at the threshold of a new era in human history. The technological innovations we've explored, from the Raptor engine and advanced heat shields to in-orbit refueling and AI-driven autonomy, are not just engineering marvels, but stepping stones to a future where humanity extends its reach beyond Earth. The economic, social, and philosophical implications of this endeavor are vast and complex, challenging us to rethink our place in the cosmos and our responsibilities as a spacefaring civilization.
Absolutely. What stands out is how the Starship project embodies both incredible ambition and pragmatic problem-solving. It's a testament to human ingenuity and our capacity to dream big while also tackling the nitty-gritty technical challenges. As we move forward, it's crucial that we approach this new frontier with a balance of enthusiasm and responsibility, ensuring that our expansion into space benefits all of humanity and is guided by our highest ethical principles.
Indeed, the Starship project is not just about reaching new worlds, but about creating a better future for our species both on Earth and beyond. It underscores the importance of fostering global cooperation in space exploration and establishing robust governance frameworks for this new era. As we conclude, it's clear that the success of Starship could mark the beginning of a new chapter in human history, one where the stars are no longer just points of light in the sky, but potential homes and stepping stones in humanity's greatest adventure.